I have a little website that I run, and I do, in addition to you know, selling Arduinos and chips and things, I do a lot of software consulting and firmware and other enterprise-y stuff that I can't talk about. So basically my presentation is on, you know, and I did a TriEmbed presentation that I think there's video of, right, on TriEmbed website, and I can put we can find a link for it, but and that was basically an introduction to sort of the AVR programming on Windows and Atmel Studio. But for this one I wanted a little bit different focus on just kind of specifically migration from the Arduino IDE, and so that's where my why, you know, why use, at least when you're on Windows, why use this tool over using the Arduino IDE. And so, you know, you can kind of see them right here. It's, you know, it's using more standard C++ than using, as Pete alluded to, the kind of the voodoo that happens with the Arduino IDE, where it pre-processes your code in ways that aren't entirely clear. And so if you are a seasoned developer, you know, and you're like, okay, I've got a source code library and I've got some headers and some, you know, where do I integrate those into my code? Well, let me, you know, normal C++ developer, you might say, well, let me put them in a libraries folder, you know, that's a subfolder of my project, and you know, and I'll have them organized that way, or maybe put them in a namespace. And you know, you can't do that kind of stuff with the Arduino, so it lets you develop in a more traditional C++ sense. It's free, as in beer. It's a do I say it on this? I cut and paste this from my slide from a couple years ago. But the Atmel Studio is a IDE that's based on Microsoft's Visual Studio. So Microsoft has this program where they can people can build on top of their IDE platform, build their own IDEs, and so that's what Atmel did. And it's free, by the way. They give that away, so anybody can make their own IDE for their own thing that's based on Visual Studio. But some of the benefits of it are that it's extremely customizable. It's, you know, and you can do lots of plugins, and I'll show you that. You can also use general Visual Studio plugins, and there's tons of those. And you can also get rid of the Arduino bootloader, and actually it's easier if you get rid of it. It's easier to get rid of it than to try and keep it when you're developing, at least when you're doing your own programmer. So you get, I think on the, like the Uno, the bootloader is like, is it 1K?
2K.
Is it 2K? So on a 32K chip, that's a significant, you know, if you're running up to the limits and you don't want to go to the next bigger chip. Built-in simulator.
So do you, and this probably goes for Pete too, so are you programming the Arduino through the SPI port?
Yeah, you can do, yeah.
Or are you doing it through the USB port?
You can do either. So, and that's...
I've never been able to get it right through the USB port. What was that through the SPI?
Okay. The way to do it through the USB port is actually kind of close to the way Pete did it, where you could actually build your executable and then you could run AVRDude to have it upload, you know, the same way you would do it as if it was from the Arduino. So you could just use the IDE to build your code and then run a little, you know, script. And I've done it that way before, where I've wanted to keep the Arduino. I've done it for customers where I wanted to keep it off-the-shelf Arduino sort of thing.
So, yeah, with that scenario, you would use a programmer like this, and the AVRDude command is nearly identical to what you would give the bootloader-based programmer interface, but instead it's directly programming the chip.
And what Carl was asking about was the, this,
It's 6 pins somewhere.
yes, this little thing right here is called the ICSP port, and I think every Arduino has one, and it stands for, I think, in-circuit system serial programming, something like that. And that's actually a hardware function of the AVR chip that has circuitry built in that allows, that's how they get programmed before they have an Arduino. And it's a blank chip. They use this thing to upload the Arduino bootloader onto it. And so when you develop in using Atmel Studio, it's set up, and I'll show you a couple pieces of hardware that can do it.
Yeah, so with
Right.
this board,
I can grab mine too.
just plug it on like this. Assuming that the pins aren't bent. Anyway, it just plugs right on.
They might be bent.
He's got one.
Yeah, I've actually got a few. This is one that I made myself, which you need a line that says here's where.
Yes.
So this is a 6-pin programmer that's actually using a ATtiny that has a special program running on it that has the same 6 pins, that connect. This one is, I think it's I don't know, it's like $3 worth of parts, and probably, about $400 worth of labor, and you can, make your own. There's a couple, and you can buy something just like this on eBay for $4 or something. It's really easy if you. But then the official programmers that Atmel makes, they actually have a couple of them. And this one.
This is one of them. Right. This is the.
Oh, that's an official.
That's the Mark II. Yeah.
Oh, okay.
But this is now obsolete.
Right. And that one. There's several different interfaces. So I said that was the ICSP, and it uses a SPI like bus to talk to the chip to upload new code. And it also has a debugging interface called debug wire that's this proprietary thing. And one of the reasons you never see it on, I think you can do it on Linux, but you never see it done with the clone tools like this thing, is that the debug wire interface is proprietary, and they haven't released it. And I think somebody has to reverse engineer it or something to get it to work. So with that interface, you could actually debug, and that's one of the things that the Atmel Studio supports, is debugging the code. Now, I can show you that in a minute. One of the other interfaces for some of the larger chips is a JTAG, which is another, is a system used on ARM chips and other more larger hardware chips.
What would the price point be for one of the programs that supported the debug wire?
I think
$50 or is it $300?
this might be the cheapest one. This is the called the AVR Dragon, and so this is sold by Atmel, and it's in the neighborhood of $50. It might be $55 or something. You might be able to find it cheaper. And I've had this for years. They have a reputation for being very fragile, and I'm starting to suspect this one might be acting up. Apparently there's some flaws in the design where some voltage regulators give out or something. But basically you can see there's the neat thing about this one is that it supports the debug wire through the ICSP or ISP. That's the same 6 pins that connected to the other one. The pinout on this is identical to that. but this one doesn't support the debug wire functionality. This one does. And it also supports this JTAG, and JTAG is used on the larger AVR chips, like this Mega 1284, which you can't really read, but is that a total? Yeah. It's that's the biggest AVR chip that's in a DIP form factor that you can buy. So it's one of my favorite chips to use. I have a ton of them. And it's got I think 128K of flash and 16K of RAM, which is huge.
What's the price point on those?
About $8. You can find them a little less. I'm trying to remember. I know somebody who sells them in the area, but I'm trying to remember what he charges. But yeah, it's in that neighborhood. $8, maybe 10, some places. But anyways, that one supports JTAG, and I think one of the differentiators is the size of the memory, because it has greater than 64K. The 6-pin interface won't work for it, or something. I don't know, but at any rate, it supports both of those, and this thing right here is the high voltage programming. So that's there's an additional interface that all AVRs support called high voltage programming, and that's it's possible, like I did earlier, to put your chip in a state where you set the flags wrong and it won't. You turned off. Basically, I turned off. I think I turned off this interface to where it said it's not going to listen to it anymore. So the high voltage is actually by high voltage. I think it gives one of the pins like a 12-volt pulse, and it's designed for it, so it's okay. You know, any other pin you'll fry it, but I think it's the reset pin or power pin or one of those. When it sees a 12-volt pulse, it says, "Oh, I'm going to go into super secret high voltage mode, and I'm going to let you just rate." And so that's how you can unbrick a chip. One of the problems is that a lot of times on a circuit like this, you don't know if it's safe to put 12 volts on that one line, because you don't know what else it's connected to. So you could try it.
I think it's probably also worth mentioning that one of the example sketches for the Arduino is a programmer, so you can use that with AVR Dude, so you can have USB to the Arduino as a programmer and then have the SPI program another chip.
Yes, and that's good. I actually just kind of didn't mention that, but that's a good point. There's also, I have a shield at home. I didn't bring it because I had a box full of stuff and I had to cut it off somewhere, but there's a high voltage shield that has the little charge pump to give it the 12 volts, and I've used that to, the high voltage is nice when you've bricked your chip and it's not responding to normal commands. And then the other, so that's the cheapest debug wire interface. The nicer one, and this, the Dragon is nice too. I mean, it is nice, but it has its quirks, and it occasionally, I don't have to reboot my machine, but I have to unplug it and plug it back in, or it like stops responding, and yeah, sometimes it's a little finicky. This is the most recent Atmel their robotic programmer system, and this one's a little pricier, and
So this is the follow-on.
this is probably
That's the follow-on.
the follow-on, and it's called it's just called the Atmel Ice, and it's prettier too. I think I paid a little more to get one that came with a case, and the cables that come with it, but it's actually just a USB, and on the other side it has these little tiny 1.27 millimeter connectors that it comes with and actually it doesn't come with, but one of the reasons it's more expensive is that you have all these little add-ons. I'm starting to learn with the
You know, we can zoom that thing out.
that might.
Yeah,
might
hit
help.
the zoom button. That's better.
That's much better.
We don't need to watch the dust mites climbing around on the
Yeah.
pads.
All right, this is much better. All right, so you can see these little connectors connect into that, and on the other side it has a 6-pin connector, a JTAG connector, and it also has an arm. So that the one thing this does that the Dragon doesn't is it supports their SAM line of chips, which is is Atmel's Cortex M line of chips. So you can, so it's, and I'm gonna just make up some numbers. I think if you just buy the circuit board without the case and the add-on cables, which are mandatory, so you can't not buy them, but I think it starts at $50, and with all the add-ons, it's like 85, 90 bucks or something. But if you consider, you know, that if you program more than 5 chips with it, you might have, you know, saved money versus buying a whole Arduino. You know, if all you want to do is, you know, if all you want to do is make something like that, you know, it's a lot of extra. It's a lot cheaper, you know, to buy, or something like. Oh, I don't have it. Oh yeah. So, or something like this, and this is a good. So here is a little adapter, not focused. Right. This is a little 6-pin adapter that you can use to program. You can plug that cable into, and then wire it to the right pins on the. You can see right here. Actually, I have it wired. That's a little tiny 85.
I built one of those.
Oh yeah, yeah.
This
One of these, and I think I have 2. Actually, you can just take header pins, you know, and it's pretty easy to do. Yeah, this one's a little nicer if you're in a hurry because it's labeled. It's a little sturdier, but and actually when I've made them, I think I've taken bent header pins and they, you know, put it as. Let's see. And I think this device, I think also supports, I don't know if it supports high voltage, because I don't know, I've only ever used it for the JTAG or the 6-pin interface. I haven't, high voltage isn't something you use that often. Let me, oh, and it does have, actually, for your 85 bucks or however, you do get this thing. So you can, you know, if you have a custom board that you want to do custom things, you can do that. And I'll actually, that's a good point to bring up that in my demo, I was going to, after I fried this thing, I was like, well, I'll use my, I have an Arduino Mega. And I was, you know, it's pretty similar, but I was going to, you know, demonstrate, well, I'll just use this one instead. But the problem with this one is that this chip is a much more powerful chip. I don't know if anybody's familiar with the Arduino Mega, but it has the 6-pin interface, but it does not use that for debugging. I think you can upload code with it, but it doesn't have the debug wire. It has JTAG on it, and so in order to get the JTAG to work, I think you have to figure out which pins.
I think it's on the back. The one's up at the top.
The one's
of
up there?
screen. Yeah, it's up there.
So yeah, you have to manually connect them, and that's where this thing would come in handy, is if you want to manually do that. But I didn't take the time for this demo
They
to.
both use SPI. JTAG
You can
is
upload-
SPI, and the other thing is also
Sure,
SPI.
sure, but they're
But the protocol's different.
right, and they're Right, and the difference though is the JTAG supports debug, where in their protocol, whereas the SPI does not support debug. So, and the debug wire protocol that's also in that is not supported on this chip. I think that's the case.
Have you found the debug features useful when you're developing?
Yeah, huge. That's what I was going to get at. That was the whole reason. Like I'm big on being able to debug, and I can show. I can show, run it and show you. And I don't know how bad it's going to look on this low resolution screen because it is, it's a big IDE, so it's, and this is a pretty decent machine. So it took a little bit to start up, and this is a Core i7 with SSD, so it's still, but once you get it up and running, it's fine. But yeah, and it doesn't look too good.
Does this have anything to do with Visual Studio?
It is. Yeah.
It's built on Visual Studio.
Yeah. So that's what I was saying. Microsoft gives the platform for that. Anyone who wants to.
Explains the slow load.
Right. Yeah.
Well, it's also written in Java.
It's written in C# actually.
No way.
Oh, is
Yeah,
it?
yeah. Microsoft debug environment's not going to be written in Java.
Oh, that's true, yeah. They don't like Java.
So let me see if I can walk through an example of comparing, we were talking about like code organization, and this is one area where it shines. I was trying to find the largest Arduino code that I could think of, and this is a copy of the Marlin firmware that's for 3D printers that does all the CNC calculation and G-code command, and it's a pretty big program. So I figured it would make a good demonstration. It's the biggest Arduino program I could think of off the top of my head. So let me just open it in the. So there's a lot of stuff in here, and open the main program. And it doesn't start up too bad, but again, this is a pretty fast machine. So you can see if you're trying to navigate and learn what this thing does, there's a lot of stuff in here, and you want to switch files, you got to drop this thing down and scroll through, and let's go to vector 3. Okay, that opened it, but it didn't even highlight the tab here. If I wanted to go to the header versus the CPP file, I have to. Well, at least it goes back to where it was. I think it used to not do that. So, but it's just sort of painful to navigate. And then if I wanted to find, where this thing was used, it's just not. It's not. It doesn't scale well. When you just have one file and you're blinking something, it's no big deal. But when things get really large, it can be really painful to work in this, in this system. So, so what this one of the new things in version 7 of Atmel Studio is the ability to import Arduino projects, and I actually. I've sort of already talked about this. All right. All right. All right. All right. So, so you can have the best of both worlds and use, one of the nice things about the Arduino is the community and all the libraries they have for doing things. And you can drag stuff in, you want to use I2C, and there's a ton of libraries for that. But then there's a lot of advantages to doing things, the way Pete and I like to do in a regular IDE. So I kind of came up with 4 ways of having having it both, having it both ways. And you could take your C++ project that you've already been working on and throw Arduino stuff into it piecemeal, and that's the first way. You can take an existing Arduino project and manually convert it. And it used to be, up until a couple years ago, these first two were really the only two ways to do it. And I've done this several times, and it's slightly painful, but once you get past the pain, it's great. It's a one-time thing you have to do. Option 3 is what I'm going to give you a demo of for this big project. And then option 4, there's a plugin that's been around for a few years too, called Visual Micro. That what it does, and I don't have it installed in this machine, but basically it opens Arduino Sketch programs and calls your Arduino IDE or build tools under the hood, but lets you open it up in Visual Studio. So it's different than these first, these three basically start with your Arduino code, and you're migrating to now I'm working in a raw, C++ environment. The last option is you're kind of keeping your Arduino stuff around, and you could actually go back to an Arduino if you wanted, because it's using your existing files. It's like opening your Photoshop files, and instead of converting it to a PNG, it keeps it in the Photoshop format. So let me. I made a bunch of slides on the pros and cons of these, but I don't know if I need to necessarily go into them. I think I'd rather give the demo. I can put these slides up, but they're all kind of.
We can put them on the website.
Right, yeah. But they're all kind of the obvious pros and cons that you would think of for those options. So let me demonstrate how you would do. This would be the option 3 to import the existing solution, and I'm going to show too that it's not. It's still kind of new, so there's a couple hiccups in it, and for a little hello world, it works pretty great. So let me show the hello world. So let me make a new. Let me actually. Let me take your basic hello world sketch of. I'm gonna blink. This is the same one that everyone uses. And let me go ahead and save it. I need to disable the touchpad.
No palm checking enabled.
Yeah, man, I tell you, that
I
kills me on mine.
I redid this machine a little while ago, and I forgot to tweak all that stuff.
I love the gesture that says delete your file or abandon your edit. Your palm wiggles in the wrong direction, and it gives you a.
Sure, you want to format your drive.
It asked
Yes.
you for a folder and you gave it a link to PDE, so
Yeah.
you got nested.
Let me start over.
You don't need a folder.
Oh, I'm just being paranoid. So I want to make sure I know what I'm when I go to put it somewhere, that I know what I'm looking at. It's more for human reasons than
Well, it's going to make another one called link
I'm fine with that.
under your link.
Yeah.
Folders are cheap.
I actually, when I was doing this, I'll have blank 1, 2, 3, 4 is one of the reasons, because all right, so what I'm gonna do is make sure, all right, that the board that I'm targeting, because one of the things I've found is that I think when it does the conversion, I think it's actually setting it up for a particular board, I think. Or it may set your, some of your preprocessor definitions based on what your current setting is. I think, I'm not sure. It's still a little magic. But, all right, so that's what we wanted. And yeah, it's gonna save it. All right, so now what we're gonna do in here is we're gonna create a new project. We'll put them in this folder. Make sure I got it. Call it. So now it's going to ask me, well, where's my sketch? And I browse to my 2 layers of Blink and open that, and then actually here's where it figures out what board you're using. So you can select your board here, and I think this one of the disadvantages of doing it is I don't know that you can necessarily easily just change to a different board, or if there is, I haven't seen how that works. That's on the Visual Micro. You get a drop down just like the Arduino IDE that says pick your board.
So you're kind of committed to the target board once you select it here?
It's not a hard commitment. It's just a slight, pain to change. And this is new. I haven't used this enough yet to know all the, how exactly it's switched, but I know that it's not etched in stone.
This is really new, isn't it?
Yeah, this ability to import it like this is new. So then you select your board, and so this does all the magic I think that Pete was talking about, where your forward declares, where things have to be in the right order. I think this fixes it all for you. And so you can see, it did a little bit of magic here, or it did this forward declaration. And the other thing that it did was that it took a copy of your Arduino environment and just basically cloned it. So now all the Arduino headers that used to live inside the Arduino software, it just made a copy of that for you.
How much headache would it be to update a library?
That's one of my down in my slides. I think one of the disadvantages of using this. I don't know. It could be as easy as just
Pulling header file over and
pull in it and copying. That's what I do. I actually, in the Marlin firmware example, it's on the CNC I built. I use that firmware, and I've done updates, and mine has diverged so much from the original stuff that it's painful no matter what I do to try and fit things in there. But I can control it better. Where the Arduino, if I install a new version, a lot of the libraries are global, so you don't know what if you ever have to customize libraries, which I've done in the past. So there's a lot of stuff, and some of these things you won't need, but when you have it optimized, it shouldn't impact your code size. It may, and it gives you a lot more detail when it's building. So some of the options that you picked in the beginning might impact some of these settings right here. So you're asking how to change the board. If you need to change to a different board, there are some Arduino boards that run at 20 megahertz. or 8 megahertz. And so changing that is, it's just done differently, but I don't think you're gonna have a drop down that's gonna, select that. You would go to your project properties, and you can actually make a makefile too if you wanted to just do this one time and then say, I hate this whole thing, I just wanna run it from the command line like Pete does. You could, there's a way to export. You can export it, or you could make your own external makefile. If you're familiar with Visual Studio, you can have build events or script things you can run before and after the build. The tool chain is the big one. There's tons of options in here. And most of them, since Arduino is a C++ based language, most of everything you use is going to be.
So you could manually insert a switch there to set your CPU speed.
Right, and it's actually right here. So the preprocessor would be under symbols. So you see, these are all the symbols, and I don't know, and that little script that we did that said import created these, and I don't know why this is twice.
There's the speed.
But yeah, that's how you change it. So if you want to, and this is when I make my own raw C++ AVR projects, is a lot of it's not only the F_CPU is a GCC AVR GCC thing. So it's not just Arduino that uses that. So yeah, I guess that's some other flags that get set, which I don't even know what they all mean. But the other thing is that you can go in and do some crazy things with optimizations if you want.
Where does the debugging come in?
You mean this option, or you just mean?
Oh no, I meant as
In
far as
general?
being able to, when you're running, getting
Oh.
runtime data.
Simulating.
Sure. You can, and I can show you now, since I was going to try and show you on those, but I think it just might take too long. Maybe I'll do a separate talk where I just come in and debug or something, or I don't get more setup. But I can. One of the neat things you don't get in the Arduino IDE is the simulator. And actually, let me plug in my. Let me plug this guy in. Once that's plugged in, it should, so now it, and you can pick what interface, and it already knows that this particular Atmega 328 only supports the ISP or debug wire interfaces. It doesn't have JTAG, so if it was a different chip, like for example.
So was that from specifying the board, or was that from interrogating the target?
It's specified in the board, and actually, if you look at this neat little thing here, it'll actually show you all this data that, since it's Atmel, they can just interrogate the guy down the hall or whatever. So, but you can change, you can pick, and here's all the devices that it supports. These are all the Atmegas, and for each one that you select, it also has, that's gonna.
Cool.
Yeah, it's gonna open the browser, so I'm not connected to the network, but you can, and it also tells you which of the.
So they got the cross-reference catalog for all their parts.
Yeah, but it also has, your tinies, and the, for some reason it's not showing the SAMs. I don't know why. Maybe it's my project type. Anyways, it's not showing
The ARM
ARM-based
chips.
ones, yeah. It does, I've seen it before, maybe when I create a new project, you select and it can be anything, it might have filtered it because it knows I'm on it. So anyways, I'm gonna cancel that and keep 328 and then, you know, select that. And it's not actually gonna do anything right now because I'm not actually plugged in, but if it were, I could go under here and go to device programming, and you get this neat little dialog box. Apply, you know, set that. And now this is gonna fail because I'm not actually connected to anything. And if you want, actually, if you don't mind, Pete, if I
Like I
potentially,
said, you have at it.
potentially destroy your device.
It doesn't matter.
In the name of science.
Well, it's a $2.50 chip.
I'm gonna do some. Keyboards I like here. The one thing I love this laptop, but the USB port placement is just awful.